Yeah.
Yeah. Okay. So can you please mute? Yeah. So I think the recording have started. Do we get the notification? Yeah. So okay. So yeah. Thank you. So let's begin. So welcome to the section today. And today we will be starting with introduction to cloud computing. So this program is for people that are trying to want to start to navigate their journey into cloud computing, and also target mostly people in Nigeria, most of the people that are on break now due to the election, and also people that want to start their career afresh. Can you please mute your mic? That want to start their career afresh in cloud computing. Please, if you join, kindly mute your microphone. Okay, so now we're going to start introduction to cloud computing. So someone will ask me, like, what is cloud computing? What exactly is cloud computing? Now, looking at cloud computing, it sounds so abstract, and I'm like, are we trying to put something in the space or in the cloud, or how does it even look? So we are going to go into details of it today. And even if you are not familiar with, we are still going to get the what you call data center. You are going to see, like, how will I explain? You are going to see the physical structure of how cloud computing actually looks.
Yeah, you can mute yourself now. Sorry, I was trying to mute all.
Okay, so can you hear me?
Yes, we can.
Yeah, okay. So we are going to have a pictorial view of everything, and we are going to understand what is exactly this cloud computing. So follow me as we begin with this cloud computing. So if someone asks, like, what is cloud computing? So cloud computing is like you want to deliver an IT resources over the internet. Now let's now take it away from the definition. Now let's try to look it into the abstract now. We all have an Instagram, we have Twitter, we have WhatsApp. Remember that if you have your WhatsApp now and maybe your phone got lost or you have an issue with your phone and you now got a new phone. So when you get a new phone, you did a backup on your previous phone. So when you get your new phone, you try to download WhatsApp again, you register with your number, and you discover that all your previous messages, they are on your WhatsApp. How does it happen? Because your phone is, you don't see your phone again, it got spoiled or it got lost. Yet you still have all your information, your data, and your new phone that you are using. The same thing happened with your Instagram. Maybe you change your phone or you change your device or you try to use another sign in and you try to get your information also in your emails. So have you been trying to think that what exactly is the technology that is behind this? So that technology, looking at that, is what we call cloud computing. All our information, our data is stored in the cloud. So when we want to use it, we import it from the what? From the cloud. So some of us also that have our contact information stored with our Gmail. So before now, when we store our information on our phone, when our phone got lost or it got damaged, we get worried about how are we going to get this our contacts back. But now you don't even need to worry about it. If your phone got lost device or device just got broken or anything, you got a new device. Once you import, you are going to get all your contacts back. So this is exactly what we call the principle of cloud computing, meaning that we don't hold anything in a physical space any longer. We now hold it in the an abstract space. So some of us now be wondering that where exactly is this abstract space? Like where do we just throw it up? So just follow me. We are going to understand how this abstract space work and how does it look like. So like I said, cloud computing is the delivery of IT resources over the internet. So now we don't really need to do everything we do is on the internet. You just need data to get everything you want. So you don't need to have it physically. Maybe you saw it on a DVD and go ahead with DVD. You know, before we store information on flash drive, we store it on our hard disks, on our system hard disks. We just install the hard disk, we import everything we need. So we don't really need that any longer. The same thing happens to to a company. Let's say, for example, a company that have their websites hosted on a physical data center, or maybe they have it hosted on a physical space. So they don't really need to do that. Everything now, we now do it all over the internet. So what we just need to do is got a smartphone and an internet, then all our information is going with us. And if you just look back into 10 years ago and see the way we handle our information, like if you want to travel, I have to go with my system, then another hard disk. So I back up information on my system on my hard disk. But now with cloud computing, we don't need an hard disk any longer. We don't need to go and go to like people that are in Nigeria and familiar with Lagos, don't need to go to Computer Village and get hard disks there to store information and go. So the cloud is like a virtual data center accessible via the internet. So, I said the word virtual data center. Yes, that is it. But I will still bring you back to the physical data center, how it looks and how it works. So, what exactly do you do inside this cloud computing? So you're able to, for storage services, you have a storage service like database, you have it in the cloud. We have all your servers. So imagine, just look at it. Imagine you having your system. Now, if you want to travel, you go with your system. Now, imagine a world in which you don't really need to go, with, okay, let me put it in this way. Maybe where you are using, I don't want to use the word that system, that might be too, okay, let's assume you work in your place of working, you have like different servers, or let's say different desktop, like 4 of the desktops. And you want to travel, for example, and you are like, okay, I want to work from another place, not in my workspace. How do you want to go? We have to go with your desktop to that place and start working. Or maybe you want to go and have your vacation somewhere, and you remember that everything you need to do is on your desktop at office. Now, cloud computing brings a very good solution to this, in which you don't really need to do that. You can have your desktop in the cloud, in which you can begin to access your desktop from your own system in the cloud. So with my system, I can go into like different systems. Like, for example, I'm talking about PC now. Maybe I have like 200 PCs, 200 personal computer in the cloud, and I'm accessing it from just one single computer. So instead of me getting like 100 computers, I only need one to access all the remaining 99. So I'm going to show us now how that works. So that's what this does. So you can have your servers, you can have your compute power. So for example, if your PC, now the PC you are using, maybe you have a good PC with let's say 32 gig RAM. So that's the more like maximum you can go. But with cloud computing, you can own a PC with 128 gig RAM. So depending on what you want, you can get it in what? In cloud. So it also helps with networking. You don't really need to fix the networking yourself. So networking has been fixed. So you use it for analytic and artificial intelligence. So now when it comes to this artificial intelligence, it's also very helpful, especially when it comes to like the compute power. Let me take, for example, there was a project I was doing last year with machine learning. So I was trying to build a machine learning model in which we detect suicide, a suicidal tweet. Maybe someone go on Facebook or Instagram and just post any suicidal tweet. So the machine learning model will determine, we try to say, okay, this tweet is suicidal, and immediately they can send help to that person to prevent suicide. So I have like 10 million, the data set I'm using is like 10 million data sets. And the system I'm using then, I think is 16 gig. When I'm trying to run this model, my system hung for like 2 days. I couldn't do it. Why? Because of the compute power of my system. It couldn't meet up to what I'm trying to do. Now look at that. Look at how cloud computing solved that. I can go in the cloud and get a maybe 128 gig RAM system and run my machine learning models without any stress. I'm not doing it on my system. I'm doing it what? In the cloud. And it's going to be what? Work perfectly and fine for me. So when it comes to augmented reality, it's a new technology that comes with 5G. And augmented reality will actually be more interesting when we go to the area of 6G. So maybe later we'll talk about this augmented reality. So for security service for data and application. So this is why cloud computing is very, very useful, when it comes to security. Like we are getting to the age in which security should be one of the most important things, because we have data everywhere. The rampant growth of AI is actually giving us the impression that then the next line of action is going to be in data security. So all of these is more like cloud computing have solved the problem that we face in the present and we might encounter in the future. So now look at this image. So this is more like in the cloud, what we can get in the cloud. So this is our laptop with your phone, maybe your tablet or your desktop, or even if you are using your servers. So you can use servers to go inside another servers. So inside the cloud, you can do different things. You can do monitoring content, you can collaborate with people, you can communicate. Take, for example, let me give us just a simple example. Some of us are familiar with what is it called? With this Microsoft Teams. So if you have been using Teams and you see the way a company is using it, that they are collaborating, everything is based on the cloud. Look at how seamless the communication is. You can easily chat your teammates. Maybe you have an issue to fix, just chat them up to talk. Quickly fix it, or quickly fix a meeting. Everything is it's done in the cloud. That is what is this thing is actually fixing when it comes to finance, database, creating runtime, identity, when it comes to authorization and authentication. Like if you want to have access into a building and you put your access card and you give it the authentication. How does this authentication works? It's what this is actually fixing the cloud. So these are what many things, one of the solutions that I can. So this is more like the cloud, and this is what you trying to access it. It can be through your laptop, through your phone, your tablet, or through your desktop, or through a server. So that is what like a big picture of what cloud computing is. So now, looking at this cloud computing now, what are we looking at it like then? Why is it now the benefit? Why are we actually adopting this cloud computing? What are the benefits? Why is it important? Like I said earlier, leveraging on cloud computing will give you a lot of advantage, and which one of it is it will save you a lot of cost. One, and which is very, very one of the most important thing when it comes to computing, will save you money, it will save you your data, it will save you time. So as using cloud computing, and one of the major area that is very, very important when it comes to infrastructural cost, because you don't necessarily need to build infrastructures for yourself. Take, for example, a company that build an infrastructure, maybe a data center. Let's just use this in abstracts. So let's say 1,000, I'm just using that as an abstract. Maybe it costs $1,000 to maintain every month. Migrating to the cloud might cost you like 1/4 of that cost, let's say $250 to do, instead of what, $1,000. Now tell me, wouldn't you want to migrate into the what? Into the cloud. So with the cloud, you can easily scale and be flexible. There is a lot of scalability and flexibility. Like I said earlier, you can actually scale your servers. Maybe you have one servers you are using. Okay, let's use this as an example. Maybe you run a what's it called? You run an e-commerce website. So when you run an e-commerce website, so you have like 1,000 clicks on your website. Maybe let's say during Christmas, you predicted that you're going to have like 10,000 traffic. So before, the way you do it before is you bring down your website, you upgrade it so that it can take like 10,000 traffic. But with cloud computing, you just need a single click and it will scale it to like 10,000 to scale its capability to accept what 10,000 traffic. And if you don't have up to that 10,000 traffic, it will scale it down back to your 1,000 traffic with just a single click. And we don't even need to be there. You just have to give it an instruction. This time, do this and do this. So it's very flexible and helps in scalability. It's like I said, cost saving, and it helps in better collaboration because you collaborate better in the cloud. Because people you are collaborating with, they can be anywhere. Like most of the time, I work with people in like 7 different countries at the same time, and we collaborate together. And this is very helpful with the help of cloud computing. We have advanced security, so we can able to prevent our data. So those are what the main benefit of cloud computing. Like I said, anything that saves your money, your data, and your time is worth investing in. So, and that's 3 things cloud computing comes, and what it solves that problem. So now, when we are looking at that, what are now the types of cloud computing that we have? So in that area, we have, so if anybody has any question, you can put it in the chat or just ask me. So under this, we have 4, like they said 5, but I will explain the 5th one, but it's mainly 4. So the first one is the private cloud. So we are still going to go to shared responsibility now, and we're going to look more into this private cloud, public cloud, and this. So we have the private cloud. So the private cloud is like managing the whole IT infrastructure by yourself, by your company. And you don't want to share it like, okay, we only want this cloud for our company. We want to manage it by ourselves. We don't really want any other person on this. We don't want any other tenant. We only want our own users to be in this cloud. So that's like the private cloud. So we have the public cloud. So the public cloud is the one that is available for everybody to use. So, and there are other companies that actually operate in these public clouds. So the company's own IT infrastructure is managed by a single cloud provider. So we have a single cloud provider. So this cloud provider are the one that would manage this platform. So we have we have the Oracle, we have Microsoft, we have Microsoft Azure, we have Amazon AWS, we have Alibaba Cloud, we have the IBM. So those are the public clouds that we have. So we have what we know as the hybrid cloud. So the hybrid cloud it's the combination of both private and public. So most of the companies actually use this hybrid cloud to save a lot of cost. So some companies that want some of their information to be on premises. So private cloud, we must call it on premises, on-prem cloud, like on premises, one on our premises. So most companies that want to share both private and public cloud, like maybe they want their vital information to be on their own private cloud, and they want other informations to be, maybe they want their front. Let me just use that as an example if you can easily get it. Maybe they want, let me just use that as a picture. Maybe it will be easier to get. They want their front end to be in the public cloud, and they want their back end to be in the private cloud. I don't know if you can use that one to just get the scope. So this is a very, very good technique for companies that want some of the information to be in their own premises, and others to be on the public cloud. It's actually the best cost-saving strategy for the company. But the only thing about it is it has a complex networking. The networking is so complex. So it's a combination of both private and public cloud to meet security, redundancy, and reliability. So the main reason we use it is because of security, data security, data privacy. So you don't really want some of your data to be on the public, because once you put it on the public cloud, it's not everything that you have control over. But if you want to have the full control over it, then we go into the hybrid mode. So the fourth one is a multi-cloud. So this multi-cloud, in which you have your infrastructure shared by different cloud providing platform. Maybe you have all your infrastructure both on AWS, Azure, Oracle, you have it on GCP, Google Cloud Platform. So in that case, we have multi-cloud. So another one that we have, it's not that common, it's just in that case is the federal cloud. So that one is mainly used by the government. You know, the government can share a public cloud, and they might not want to, so they have what we call the federal cloud, but that is not that common. So we still count it as a private cloud instead. So these are the types of cloud that we have. So that will now lead me towards what is called the shared responsibility. So when it comes to, shared responsibility, so first of all, I will take, before I go to, I will do the, let me explain it before I go into the shared responsibility of what the public cloud. So now let's go to shared responsibility. Let's see how this thing works on each of this cloud. So there is something we call different services on the cloud. So like I said, this is the on-premises, which is a private cloud. Sorry, does anyone has a question? Oh, okay. So we have the on-premises, this is the private cloud. Then we have infrastructure as a service, platform as a service, then software as a service. I'm going to explain that now under this shared responsibility. So let's start with the first one. So when we are talking about on-premises private cloud, what it actually means is you yourself, you can look at this, you manage, the cloud provider will manage this. So if you are considering a private cloud, then you will manage everything, the data and access. You be the one to manage it yourself. All the applications that you be running and be running on it, you manage it yourself. You manage all the run times. You manage your operating systems that you want to use. You manage all the virtual machines that you want to use on your cloud. You manage the compute, you manage the networking, you manage the storage. So it's more like a whole thing that you do from scratch to the end yourself, and you keep on maintaining it all by yourself. But if you are not using a private cloud, like you now outsource it to a public cloud, then they have 3 different services they can offer you. So you can see this one is a private cloud and this one's their public clouds. So in the public clouds, so you can now decide, okay, let's assume I as an individual, I want to use the public cloud. Then the first thing is, which service am I using in this cloud? So these are the three service model that we have. We have the infrastructure as a service, we have the platform as a service, and we have the software as a service. But before you go into this, there is a general shared responsibility between the cloud providers, which is you as an individual, you are responsible for the security. Like, okay, the cloud providers, they are responsible for the security of the cloud platforms. So like AWS, Azure, GCP, that's a general responsibility. They are responsible for the security of the cloud. But you, as an individual that is using the cloud, you are responsible for the security in the cloud. So that boils down to the application you are running in the cloud. What are the things you are doing in the cloud? Then you are responsible for what? For the security all by yourself. But they themselves, they are responsible for the security of the cloud. Take, for example, making sure the cloud is available in different availability zone. We are still going to get to availability zone, the data centers. I'm still going to explain that. I want to have a picture explanation of that so you have a real idea of what exactly is this cloud. So they are responsible for the security. They don't make sure it's safe. When the platform is safe to use, there's no issue with it. It's up and running. It's available anytime, anywhere for you to use. But you as a person, once you get hold of it, they give you, okay, you are using these resources in the cloud, then you are the one responsible for what? The security in the cloud. What are the application you are doing? Is the networking okay? Is everything okay for you to use in the cloud? So take, for example, you are taking this service, which is infrastructure as a service. Now, what you are responsible for the data and access yourself. So that's come to identity management. Then you are responsible for the application you are running in the cloud. So you are responsible for the runtime. How does it want to run in the cloud? You are responsible for the operating system. And you are responsible for the virtual machine that you want to use. But the provider will manage the compute, you will manage the networking and the storage. Okay, like someone has a question. What's the question? Do you want to say it or you want to type it?
I would like to really say it. I don't know.
So,
Can you hear me, please?
okay, I can hear you.
All right. Sorry to cut in. I just want to clear this understanding in my head. You said it's the providers are responsible for the security of the cloud, while you as the client you're responsible for the security in the cloud. So I want to understand the term security. Are you talking about the security in terms of people breaking into your space, or so I want to understand the difference, because if, for example, there is this hacker that wants to hack your system, is it that AWS or the cloud providers are responsible for people not gaining access to your resources on the cloud? So because the way I'm seeing that statement is as though, if, for example, they are able to give you all of the access they require, they grant all the normal access, which maybe authentication and all, and then maybe your own clients, your own staff, they are the ones now performing shady things in your infrastructure. So that means you will be responsible for those ones. So that's what I understand yet, but I don't think it's what you're saying. So I really want to understand.
Okay, so now let me do this. Let me take it out of this and give you a picture explanation of this. So now let's assume you buy a land. you build a house. Do you understand? If you have a house, let's assume you build a house. So now the let's say, let's use this in this time. I'm trying to see what I can use to explain so you can get it. So the government is responsible that your environment is secured, right? Like the city is secured, you can move freely without any security threat, right? So you as an individual, you are responsible to ensure that your own house is what is secured. I don't know if you get my point. So now in that area, the infrastructure they are giving you, they ensure that it is secured. But you as an individual that you are running an application inside that infrastructure must ensure the security of what you are running in that infrastructure that is provided. So just like the infrastructure is safe, but if you are running an application, take for example, you want to run an image from, let's say, one of the provider to run your container, but the image you want to run, it's not, let's say it's a counterfeit. So once you run it, the people that actually planted maybe a bug in the image, they will get access to your application. So if your application is being hacked, then that is not the responsibility of the cloud providers. I don't know if you are getting it.
I'm following you.
So it is your own responsibility to ensure what the security of the application or what you are running inside the infrastructure that is provided for you. So if it is a platform that is given to you, it's also boiled down to you getting security of what you are running inside the platform. Because the cloud provider cannot take the responsibility of the application, your own application, your own website, or your model or anything you are running inside the infrastructure, but they ensure that infrastructure is okay for you to use. So I don't know if you get the answers to your question.
Yes, yeah, it has cleared a bit in my head. Yes, well, maybe as we go on with the program, I will get better. But it has cleared a good percentage.
Okay, I think they have another question in the chat.
It's the same question as Mr.
Okay.
Isaac asked.
Okay, yeah, thank you. So if you're renting the infrastructure, so it should be like, okay, they are responsible for the compute, they will provide you the compute, the networking, and the storage you need. So it is now left for you to select which of the virtual machine you need, what is the OS you want to use. Am I using Linux, Windows, Mac, any of the OS I want to use? So it's now left to you to choose which of the runtime, left you to choose the application that you want to run on it. So your data and access, your identity management, your data is your responsibility, but they will provide the infrastructure that you need. Example of infrastructure as a service is when you are using in AWS, we call it EC2. So in other different cloud platform, we call it in different name. Okay, so let me do this for us. So I want to go to, let's go online and check. Can you see my screen?
We can still see the shared responsibility slide.
Okay, I'm trying to, okay, sorry. Oh, just a minute. I'm trying to open. Okay, maybe I will do this. I will do this later. I will do this later when I want to show us that. I think that would be cool. So I will show us this. You see what I'm actually talking about. So let me just go. So example of it is when you want to run. I'm trying to see. I want to see there is something in the chat. Mhm. Yeah, so someone is typing in the chat. Well, it's exactly like that's what I'm saying. So the cloud infrastructure is secure. Now left for you to configure your application and how you want the networking to be. I want what the security to be. So that's what is saying in the chat. So let's continue because of our time. So the second one we have is what? The platform as a service. So in this, it's more like just forget about the technical time. Let's go to what the English time, like the first one, we said infrastructure. We give you an infrastructure to use. But here now, we want to give you the whole platform to use. So in that platform, we already have storage fixed. They already have networking fixed. They already have the compute fixed. Virtual machine operating system, the runtime is fixed. What is just left for you is just to bring in an application that you want to put on the cloud and the way you want to control your data and access. But I want us to know one thing. That is very important thing to know, that the public cloud will never control our data and access. So your access, when it comes to access and like identity management, Active Directory, when it comes to Azure, when it comes to that, the cloud platform will not manage it for us and our data. It is left for us to choose how our data will be managed. So when it comes to the platform, it's like we are using this platform, they have everything already. Example of this is I'm using like a database. Maybe I'm using RDS. That's I'm talking in terms of AWS, relational database now. So if you are using it, everything is already fixed. So what you just need to configure run our application, then give the access to who we want to have give the access to those we want to give access to, be able to access this. Then now we are going to manage our data. That is the only thing that is left for us to think about. Others have been catered for, but by the cloud platform, I need to run now because of our time. So when we now come to the software as a service, so more like we are using everything, you have provided everything for us in the cloud. All we just need to bring is just to control it, just our data and access. So when we come to software as a service, one of the main examples is when you are considering, let's say, something like Lambda. So when we are talking about Lambda, we're talking about Lambda, when I'm talking about serverless technology. So that is where we look into more like software as a service. Even like, let me just come back. Let's look at the word Teams. Like Teams I used before, Microsoft Teams. It's more like a software as a service. They have everything in it. So what we just need to, who are the people that want to give access to the Teams, and our data, how we store our data. Do you understand? So that is what, if we are taking in a software as a service. So that is now a brief of what the shared responsibility. So if we are using the cloud, it's not only left with the cloud provider. So it's now left with both the cloud provider and the user. We have to share in this responsibility. So there is a place I want to actually spend time to dwell on. So I'm getting there now. So now when we're talking about global infrastructure, so this is where I want to go. When I'm talking about infrastructure before, what is this infrastructure? What exactly are we talking about? So now I'm talking about this global infrastructure. So one of the things important is when I'm talking about region. So we are going to get in depth of this tomorrow. So what we are going to be doing is we are going to talk about the three public cloud. We are talking about AWS, Azure, and GCP. So tomorrow and next tomorrow we look into AWS. Then the next 2 days we look into Azure. Then the next 2 days we look into GCP to have the view of all the cloud platforms. So when we're talking about a region is a physical location or an area on the map. So more like a physical location in which we have the data center. We call it the region. That's a region. I'm going to explain it in the next slide after this. Then we have what we call the availability zones. So availability zone is more like an isolated solution within the geographical region. We have established before that a region is a geographical location. Now let's just take, for example, maybe we said Nigeria, Ghana, South Africa is a region. So inside we have Nigeria, we have Ghana, let's just say we have South Africa. Let's just use that area for example. We call that a region. So in that region, let's say in Nigeria, we now have what we call availability zones. Let's say Lagos, Port Harcourt, Abuja. We call it the availability zones. So those availability zones is the place in which we have the physical servers have been established. If you understand. So we have the physical, I'm going to show us this after this. So that availability zone, we have minimum of 3 availability zones. And each availability zone, they have exactly the same thing. And the reason why this is because of to make it more available. Maybe there's an issue with one availability zone now. There will still be other 2 that are working. So that is why you said the cloud platform has ensured what the security of the cloud to the extent that even if 2 physical data center went down, maybe they blow the place, there will still be 1 available in that region. So most regions has minimum the list of 3 availability zones in each of the region. So availability zone is like an isolated solution, like I said, where you have the physical data center with within a specific region. So like in Nigeria, let's say we have 3 physical centers, the availability. So we have in Lagos, Abuja, Port Harcourt. Let's say in Ghana, sorry, I don't know cities in Ghana. Okay. Let's say we have 3 availability zones also. In South Africa, we have the same thing also. So that is what availability do. So we have what we call edge locations. Say we call it a mini data center used only to catch it. So now the thing is, when we are talking about edge location, it's just like you want to bring the data file to a particular edge. Oh, how can I explain this? Okay, let's assume, when you browse the internet, there is something we call, I don't know what to call it, maybe cache or cache, or what does it, any way you call it, I just call it cache. So something like this. So when you browse on your internet and you press something, you press, why does Chelsea lose today on the internet? So if you go open another tab and you type why, you will see the next thing that is going to show, why does Chelsea lose today? Why is it showing? Because you have used it before, you have browsed it before. So it's now what? Cache that and put it in your browser for you. I don't know if you understand that. So every website that you visit, they used to say, okay, allow cookies. So these cookies is what? It's for like caching our information and storing it. So just bring that knowledge and principle to this edge location. So at each of the edge, we have what? We have, instead of repeating the same, this thing will make sense to us when we go into maybe start with AWS and each of the cloud platform, you understand this better. So instead of what? When you go to that, take for example, let's say I'm in the United States and I want to access a website that only runs in Nigeria. I think this would be a good example. So every time I run that, due to the latency, so latencies can call it like, let's say the distance. Should I use the word distance? The speed in which you can get access. I want to use the layman's term so you can able to picture it and understand it. Speed in which you can able to get access. Let's say connectivity. You know, when you are trying to browse the internet now, you have like 2G compared to when you have 5G, it will be faster than one another. So just use that principle to understand what latency is. So now, if you're in the US now, for example, if I'm in the US and I want to access data in Nigeria, because of what? The distance and the location, every time I try to access this, it will take a longer time. But instead of taking that longer time, once I do it once, it will cache the information. So somewhere that is very close to me, so the region that is very, very close to me. Take, for example, I'm accessing, okay, let's use this. I'm in Ghana, I'm accessing information in Nigeria. And let's say Abuja is closer to Ghana. And the information I'm accessing is in, let's say, Port Harcourt, which is kind of far. So once I try to access it once, it will cache the information and put it in the location that is very close to Ghana, let's say Abuja. So instead of it still taking time to go and get it from Port Harcourt, it can actually get it from what? The location in what? In Abuja, which is closer to Ghana, and it will be very fast to access. So that when we get into each of the platforms, we understand this more. So when we're talking about additional information, I just put that. So there are more availability zones than there are regions. So in each of the region, there is minimum of 3 availability zones. So it's more for availability and reliability. So that's why we have that. There should be at least 2 availability zones per region, but most of the time, most of the cloud platforms, they have like 3. If you look at AWS, mostly AWS, some regions, they have like 5, 6, 7. But mostly most of them, they have minimum of 3. So we have each region is located in separate geographical area. We have different geographical area that they are being located in. So availability zone are distinct locations that are engineered to be isolated from failures. So the reason why we have different availability zones is because of isolation in when there is to be isolated from failures. That's why they are far from the same. One is in Lagos, Abuja, and Port Harcourt. Let's assume something happens in Lagos and it blows up or there's an issue. Abuja is still within this region, but it's kind of still is isolated from the one in Lagos and isolated from the one in Port Harcourt. So one is down, we can see access the remaining 2. So that is the principle of availability zone. Now, before I've been talking about cloud computing, data center. How does this even work? Is it an abstract? Do we just show it somewhere? So now I want to explain how and what it looks like. Now, this is how a data center looks like. You can see this is one rack, 1, 2, as many as you like. This is how several racks. So each of these is a cloud. This 1, 2, 3, as many 1, 2, 3. They are being racked. So each of it can be a cloud or 2, depending on how many servers it has in the cloud. Let's just, for example, this is a rack with 1 cloud. This is another one. So we call this a cluster. This is another cluster, like because we have different clouds that are together. It's a cluster. So this is how a data center looks. Now, looking at this, what is inside this data center? What is here? What makes up the server? What makes up this compute? This stuff like this. So this is what you are going to see in each of these racks. So this is a server. This is the front. So this is an HP, a Dell server. So we call this a bare metal. This is an HP. This is the front. This is the front server. So this is the front. Here is behind. This is the back. So if you should look at this back, you will see this is the power that is going to connect it. I'm going to show us here again. Okay, I'm going to show us in the next one. So this is the back. So here you will see this is the 2 power source that will connect it to the rack. So looking at this, you see these 2. These are what we call the NIC. So these are the NIC card. So we call it for the in-one interface for networking. So what is the function of this? This is when we want to connect it to this is what we call the network switch. So when you want to connect it to the network switch, you can see this one of the server, depending on how many gig this server is. But looking at this server, this looks like an 100 gig NIC port. So from this switch, you route because we have like you have here. Okay, I think let's go to this. Okay, looking at this, you see 1, 2, 3, 4, many of these on this rack. So as you have many of these on this rack, so what you are seeing there is like you have this, like 24 of these on one rack. So how we will connect them together for them to be able to network? That is what we do with this switch. So look at this is a switch. We call it this is a 32SIM QSFP. QSFP. So this QSFP is more like 100 gig. So from one of these ports, you can split into this NIC. This is for the networking. So it's one that actually routes all these servers together. So looking at this, we see what we call the iDRAC. So this iDRAC is like the management. This is the management. What's it called? This is the management network. This is the one that controls the management. And in each of the server, let me go from, mostly in each of the server, you see them with two different switch for the networking. So, so it depends on how this server is being built. But looking at this, like you see the picture, let me go back. The picture of this, yes, you can see that this is one of it, 1, 2. We have this can be any other thing, might not be the previous one I showed. This can be another one. So we have like many of it here. And how are these things connected together? It is what we call what? It is through this switch. So someone is that, can you ask your question? Or okay, let me check this chat. It's like a lot of questions are in the chat. Okay, someone is asking. Okay, let me go. Which is this? Can you ask your question? VPS and now DP. What do you mean by VPS and now DP? Then we have an example of PASS Heroku. It helps you deploy. So when we are talking about a platform, just see that you have the whole platform. The only thing, okay, let me go back. Let me go back. So in a platform, what you're actually bringing in is your application. The data and the access management depends on you. So anything that offer you this is more like a platform as a service. So anything that offer you a service that you're only bringing in your data and access management is a software as a service. But anything that will require you to bring in your data, access management, the application, the runtime, the operating system, virtual machine is infrastructure as a service. So someone is asking, in my opinion, if infrastructure as a service is the best for starter, I hope I'm right. So as a starter, you need to start from somewhere. And the first thing as a starter, the first thing you will play on, let's take AWS, for example, is the EC2, which is more like an infrastructure as a service. So that's the first thing you have to get used to. So I can say yes. So it's more like someone that wants to start. You need to give experience in network security and programming. So I'm trying to read the question in the chat. Okay, someone is trying to answer the question. Yeah, of course, you need experience with networking, you need security, you need programming. Yes. Platform as a service can be beginner friendly because it's cover most of the edit layers for you. Well, so as a beginner, if you want to make full use of the cloud, you need to understand how that infrastructure works before it is prepared to you as a platform. So if you don't understand what are the infrastructures in the cloud, what are these resources, how do they work? When it's offered to you as a platform, you might find it complicated. So then from there, that's why you need to understand, in fact, you need to understand it just like this layer from infrastructure as a code, understand platform as, infrastructure as a service. Then we have platform as a service. Just understand each of the service, where they fall and what is being needed in it. Someone said, can someone pursue a career in cloud computing without coding skills? Well, honestly, one thing I want us to understand when it comes to coding, coding is not all about for I in I, for this, do this. That is not all about coding. Coding actually exposes you to the realm of possibilities. You might be in the cloud and not write a line of code, and you might be writing a lot. For example, you might not be writing Python scripts, Java scripts, or JavaScript in the cloud, but you'll be writing more of YAML, JSON. Like you'll be writing more of YAML files, you'll be writing code. So they are more like the code you use in the cloud. And one thing I want to say is, if you want to take cloud computing as a career, then one thing that you must take as a responsibility or you're more familiar with is your Linux. You must be very good and sound in Linux. That is the foundation for what? For cloud computing. So everything in the cloud is built on Linux. So you might be able to understand Linux very well. So you also, nowadays, the best language that is being used in the cloud is Python. So you should be able to understand more about Python. And it depends on what you are doing, honestly. So you might only be working with containers. And when you are working with containers, you might even be focusing on Elm, you might even be using Bash. So it depends on what you are actually working with. So it's been even like what I'm working on. It's been a long time I use Python. What I write mostly is I write YAML file, I write Bash, I use Elm. So it now depends on what you're actually. So coding and programming actually opens your mind to possibilities. It helps you think, it helps you to think, it helps you to know what to be done. It helps you to read in between the line. Okay, this is what's happening. Because some things you may not be familiar with, but when you have the understanding, background in programming, you can able to interpret what you don't know. That is the advantage of programming. You can interpret things you don't know. Seeing it for the first time, you might bring some things for me and I've not seen it for the first time, but I can interpret what you are saying. Even though I don't know the syntax you are using there, I can say, okay, this is what you are trying to achieve. Why? Because I have the background, I have the understanding of programming. I know what you are trying to say to me. So that is how it looks like. So someone is like, how many regions do we have in Africa? So each of the cloud platform has their region, but I think one of the main places I think, I'm not sure, but I think AWS has a region in South Africa. I think Azure too. I think South Africa is the only region we have in Africa, I think. Oh, okay, so let me go back and handle. So now, like I said, this is how the data centers look like. And this is what is in each of the racks. So this, like I said, this is a Dell server. And this is the back of it. And like I said, so like I said, this is the iDRAC. These are the NIC ports. So this server just has two NIC. No, this is a single NIC. this is a single NIC. And if you look at this switch, it's a QSFP. So this, sorry, I'm trying to explain something to us. Yeah. Okay, so I'm saying that now looking at this server, you have a lot of them on the rack. Like, I don't want to count this. There are a lot of them, maybe 30 or I don't know. I'm just saying. So now, how do we cluster this together? So the way we cluster this together is the work of this switch. So it's the one that bring all these servers together, like I said earlier. So we connect them together. So it's part of the advance when it comes to networking. We do the networking. So that's the advantage of all this NIC. So this is the management, we call it the iDRAC. So this iDRAC is what you use to log in inside this server or your console. So for Dell, we call it iDRAC, but for HP, we call it ILO. So you can easily go inside inside this server, get how many gigs do we have? We have maybe is it using SSD, is it using NVMe? You can understand which of the hardware, where is the NIC slot, is it slot 1, slot 2, or the OCP? So every information will be gotten inside this. So when you go into this iDRAC, you're able to see the memory, you see the health, you can try it because on this rack, we have different server. So you can log in inside SSH or log into each of these server to what? To get information about the server. Maybe you want to format the disks that is inside. You want to do a lot of things in it. So now what I want to explain is each of these server that you are looking, we call them more like a bare meters. So it now depends on what we are using. So we might install a lot of things on this server. Maybe we want to, for this cloud, the cloud you are seeing now, before it can be used, something is installed on it and make it usable for you. So on this, maybe I install, let's say, I install Kubernetes on it. Maybe it's Kubernetes I install on it. Maybe it's OpenShift that is being installed on this bare metal. So don't worry, we are still going to get into that. So I just want to use as an example, just to try to give the picture of us. What does the cloud looks like? So all this, you looking in this rack is a cloud like this. So this is where everything goes. And when we are building a cloud like this, so in this cloud, you might have, I don't want to go into this now, I'm going to container. You might have 3 masters and others will be known. Okay, don't let me use it as too complicated because I can start talking about it tomorrow. So, but this is how the data center looks like. This is a rack. And if you should look at it, this is what is inside of the rack. This is the front, this is an HDL. We have this is the back. We can have it in HP also. And this is a switch. This is a 32C QSFP switch that route all these servers together, like you see it here. So does anybody have any question? I think we are running out of time. Let me see, how many regions do we have in Africa? Do we have any? Like I said.
Yes.
Okay.
Oh, yes. Thank you very much. Good evening from Nigeria, sir. So my question is this: considering the data center for, let's say, AWS and Azure and the Google GPS or whatever they call it, yes. So what's the difference? Do they have the same physical infrastructure? Or is there any modalities that are different? Maybe this one takes this form, this one takes this form.
Yeah, so they have their own structures, and let's say they have their own infrastructures. So, but we start getting to AWS tomorrow, then let's Azure, then GCP, but I will try and explain it now. So each of them have their own uniqueness and the service they offer and they provide. AWS, okay, let's take between AWS, Azure, and GCP. So AWS have the highest market share out of this public cloud. They have more resources. So they have more resources. than others than Azure and GCP. So, and most of the things they do in the cloud are similar, but they have what different names and terms and features for it. I don't know if you understand me. So they have more
Yes.
like the same service, but they have more resources than each other. Maybe in, let's say, AWS have 100 resources now. I'm just using that as an example, so it doesn't really capture what they have. So let's say AWS have 100 resources now. Let's say Azure have like 70, GCP has like 50, for example. They have resources more than each other. So me as a user, I want to use more resources that is not in Azure. I will consider what? AWS. So if I want to consider the resources that is in GCP, Azure, AWS, and I'm like, okay, the cost for Azure is cheaper than GCP and AWS, let me go for Azure because of the cost. Do you understand? So it's more like they offer the same service, but they have more resources than each other, and their modality and the way their infrastructure is different from each other. The way AWS structure have its own structure is different from Azure, but it's different from GCP, but they offer like the same thing. Do you understand? They offer the same cloud platform, but in different modality and in different structure and resources. They have similar resources, but in a different way. So someone is asking, we're out of our time, we'll be off now. How many regions do we have in Africa? Do we have any? So like I said, we have a region in South Africa, and there's an office I'm talking in terms of AWS, office in Nigeria, but we don't really have a data center in Nigeria, so we can't count it. So yeah, we can just call it a local zone, so we don't call it a region. So for the presentation, yes, fine, I can send out the presentation for us. I can send it out to us. I don't know if anybody has any question. So someone is asking that is a combination of this data center called cloud, or there are still another thing called cloud. So like I said, it might be so confusing, like what exactly is this cloud? Now I can tell you that a cloud is no more than this you are looking here in this data center. So looking at this rack, this is a cloud. This one is another one. This one is another one. But what this is actually offering, let me just use that. Maybe this cloud is the one responsible for one of the resources, maybe for EC2. Maybe this one now is responsible for another resources, maybe EKS, that's Elastic Kubernetes Service. Maybe another cloud is responsible for another thing. So they will come together. Do you understand? So just what you are looking here is the cloud. It's not more than this. So these are the physical centers that they call the cloud, that everything you see is being stored. You can see this is a lot of servers arranged together. Yeah, so this is what the data centers, they will say, we have a data centers. So like I showed us an image earlier. So yeah, we can have a big place and we have like hundreds of all these, is it a column now? All these rows like being arranged like this, a lot of them like that. So, okay, let's do something. Let's just go. Let me just go online and show us. Let's just go and check some image to play with. Oh, can you see my screen?
We can
What are
see
you
the
seeing?
data center slide. The data center slide.
Oh, okay. What can you see now? Can you see?
It's still the data center slide.
Oh, okay. Let me stop sharing and share again.
Isaac has a question.
Okay.
SMA has a question. Would we be learning Kubernetes?
Yes, we will be learning Kubernetes, but not in this program. Can you see my screen?
Not yet, please.
Oh, okay. Just a moment. I thought I'm sharing. Okay. Okay, can you
Okay,
see?
yes. Yes, you can see your browser.
Okay, let's just go to data center and see. Let's just go to images so you can see this is what it looks like. Can you see? You can see, so
Yes, you
this
can.
is how everything. So look exactly, I think this will be very good to explain. You can see all these cables that have been connected. You can see this green. You can see this is green, right? You can see this is blue and this is yellow. Look at this green now. Look at the top. These are the green. So at the top here, they are the switches. The one I showed us here. Can you see? So this switch, so it's the one you are seeing here. You can see that this is connected to the switch and is being down at the back, then connected to this one. So let this one at the bottom might be like maybe 100 gig servers. This one at the top, you can see the black. They might be like 25 gig. This blue might be like, it depends. I'm just using that as an example. So you can see that they are being routed at the top. So you can see this orange that is going above them. So this is used as the uplink. So the uplink is for you to connect one server to another to do the networking. So this is used for the uplink, and we have also what we call also for the downlink. So you have all this pool of these resources together, these servers, they are together. So this, you can call it a single cloud. Yeah, and you can have a lot of cloud in this data center that made up of one single data center. Do you understand it now? So let's look at another one. Let's just look at another picture. You can see how, so this is exactly what data centers look like. So it's not something abstract. Maybe you throw it up in the space or something like that. So this is how it looks like. You can see. So we have a lot of that. Let's see Google Data Center. You can see. So this is each of the servers. You can see each of the servers being racked in one of the rack. 6 layer of security is being used in this. Look at different server with the networking and cabling. You can see it's still cabled. So this is the, we'll call it the ventilation for it, because there is always, it ejects a lot temperature, inlet and outlet temperature must be balanced, else the server will be down and stuff like that. So let me go back to see if we have question. We'll be learning Kubernetes. Yes, we start the section again next month, in which we start talking about a lot of things actually. So if you have not joined the WhatsApp group, so I think the link will be posted in the chat, so we can join the WhatsApp group. So we'll be starting different sections by next month, which is March. So we talk about different tools, talk about Docker, Kubernetes, we talk about CI/CD tools, Jenkins, a lot of them, MyGoCD. We talk about a lot, OpenShift, OpenStack. We talk about a lot of things. So we'll be starting this section each month. We might be having workshops, sections, seminars, which are going to talk about this. So the major aim and objective is for us to build the competence and the skills we need to be able to navigate our path in this cloud computing. So we are more working together to be able to learn and understand how this thing works, because as we are talking about cloud computing, we are already thinking about another technology, which is edge computing. We have not even gotten into cloud computing, and edge computing is coming out because the thing is developing so fast. So that's the major objective of this, to equip us with what we need to prepare for the future. So someone said, okay, these data centers and edge computers, yes, exactly. So someone said, look, I was thinking of it as an eye heaven. So it's not really an eye heaven. So that is just what is inside. But with that, it's actually a lot. I can't deceive you. Can you explain how applications are managed by the multiple physical disk machine and the cloud will clarify the relationship between your phone and the availability soon? Okay, so let me quickly go. Okay, so the WhatsApp group have been pasted in the chat so you can join. So let me quickly explain something based on this question. How can you explain application? Let me go back into this slide. So looking at this now, each of these server, like we have it here, we have like, let's say 32 of this. These 32 of this server are connected together. One can be down out of this server, others will be working. So it's more like, okay, let's look at it in this way. Maybe we have each of this is 100 gig. Let's say it's just use that. Okay, let's say one of it is, each of it is 1 terabyte. We now combine 32 1 terabyte together. It will give you what? 32 terabytes. So if you move one of it, you still have 29 terabytes, which can serve you. So now, coming back to this person's question now, he said, can you explain how applications are managed by the multiple physical disk machine? So everything here is a cluster. The cluster gives you like a single entity. So it's that single entity that you have access to. So we call this a single cluster. So inside this cluster, everything is installed and configured there. So you are not going inside each of the server. You are going inside a single one like this as a cluster. You are going inside this one. And for this cluster to hold, we have a lot of servers that are being clustered together to form a single cluster for you to be able to access or do whatever you want. Let us zoom on this rack now. After I install Kubernetes on it, I install Kubernetes and I configure Kubernetes, I configure everything on it, the networking and everything. And you just deploy your application inside this cloud. So now, we now said the relationship between your phone and availability zone. So availability zone is just like a place. Okay. Availability zone is a place in a region, or sorry, let me go back. So like availability is a location. That's the term I'm actually looking for, in a region in which this data center are. So going back to this image, let's assume we have this one in Port Harcourt, this in Lagos, this in Abuja. We have it in 3 different locations in one region, which is Nigeria. I'm taking that as an example. So everything that is here and it's also here. So I'm just using that as an example. So let's say this is the 3 availability zone now. Everything that is here is here is here. So you can decide to deploy your application in all of these availability zone. So if this one is down, your application will still be running on these 2 availability zone. And you might deploy on just one availability zone, but the danger is if this availability zone is down, then your application too also will be down. So for you to give it more availability and reliability, you deploy on what? All the availability zones, depending on your application and your cost or what you are trying to do. So the person answer, you verify the relationship between your phone and the availability. So availability zone is like is location. So your phone is what you use to access your application that is one of these availability zones, one or more of these availability zones. I don't know, Abdullah, I don't know if you understand or are able to answer your question.
Yeah, I really appreciate it. Actually, thank you.
Okay. So do you have any other question? The time is good, we need to run. So tomorrow we'll continue and we'll dive deep into AWS for tomorrow and next. Then we'll talk about Azure. Then next we talk about GCP.
Yeah, I have a question. I've been raising
Okay.
my hand.
Oh, okay.
I will ask verbally. So, someone once asked me about the privacy, data privacy. You know,
Okay.
uh, coming from this angle of this science fiction, whereby, say for example, there is this cyber war, and people, some of these data centers are not located within your country, for example, and you are afraid of what the other country might do with your information. So I want to understand.
Okay, yeah. So when it comes to data privacy, each one is dependent on the government data privacy principles. So they have a terms and agreements when it comes to their data privacy based on each of the location the region is. But one thing I know about the Northern American is they don't share their data with any other region. But I know in Europe they still share their data. So it depends on that. I don't want to use the word region and it depends on the country. So each of the country has their own rules when it comes to data privacy. So in that, there is another when it comes to there's another aspect when it comes to I'm trying to remember this term that is being used. I'm trying to I want to remember the term that is being used. So it's more like data and privacy. So Azure will actually give you the data and privacy for each of these regions. Same with AWS and with GCP. So they are what we call the privacy in which you can actually check. So this one is dependent on the country that is being located. For example, in US, we have a lot of regions, and each of the regions we have a lot of availability. So depending on which region it is. So each of these regions now has the data privacy that is followed based on the government in that area. I don't know if I'm able to answer your question.
Yes, thank you. But I'm going somewhere with that question. For
Okay.
example, China would not allow you to, they will not want to connect or maybe connect with Facebook. They want to do shares for you. So some of
No,
those,
okay. No,
okay,
so I understand. So that I understand what you are saying now. So where you are going or saying that is not mainly relating to public cloud. So that one is relating to, when I was talking about shared responsibility, I talked about this, that the only thing that the platform will not handle for you is your data and access. Do you remember? Regardless of the service you choose, they will
yeah,
never undo your data or your access. So you are the one that will now determine how your data will be handled based on the government policy. Do you understand that aspect now? So the only thing they will never undo is how do you want to manage your access? Who are the people you want to give access to? How do you want to do your identity management, your access management, your Active Directory? How do you want to go about that? It won't be managed for you. You'll be the one to set that yourself. And how you want your data to be to be handled, you'll be the one to do that by yourself. And that mostly depend on the government policies. Do you understand? If your customer if you are located in the United States, for example, you will actually be banned by the data privacy of that country. So if your customer are outside of Europe, you have to, that's why you see that you receive what you call the privacy terms and agreements. You have to agree to that terms of agreement before you can actually use some service or some things like that. I don't know if you get it. So why is that? Because of what? The government policy in that region or that backs that application or the services that you are rendering. I hope I'm able to answer your question.
yeah, it's just the last one now.
Oh,
So
okay.
for example, if I face a client who is concerned about, say for example, a government or maybe something, maybe I'm working for this international government and they are concerned that this application I want to deploy should not leave Africa. So is there what are the risks involved? Or what are the things I'm going to say to them to assure them that we can deploy this stuff
No,
anywhere?
so
Well, so
like I said, when it comes to you deploying your application, if you look at the shared responsibility, I know where you are. I know what you actually need. if you're having their infrastructure on their platform, you care about your applications. And that now depends on who are your customer and what are the service you are rendering. Do you understand? So, for example, a company that have the application in a particular region, most of the time doesn't use the public cloud. Do you get? So most of the time is that they use hybrid or on-prem. So with that, they have control over everything they are doing. So if they use an hybrid, most of their information that they don't want to be exposed to a particular region is there. And in AWS, for example, do you understand? In AWS, for example, you can choose people that the customer that can access a particular region. Maybe you deploy your application in US, you can choose, say, okay, only the people in the north can access this. I don't know if you get me. So it's only people in a particular region that you see that can access that application. So you are more like you are the one in charge of your data, how you want to do it, your customer. If your customer is located in maybe in China, for example, and you don't have a data center in China. So how do you want to go about that? And you now choose the data center that is close to China. And you'll be like, this data center is only the people. So if you choose a data center that is close to China, for example, so when you deploy your application, you route it in such a way that it's only people in China that can access that application. No other person outside of China that can access it. Do you understand? So first thing you have to think, okay, what are these people that are going to use it? Okay, it's only in China. So it's only IPs or traffic that is coming from China that can access. If any other traffic comes from another country, they won't be able to access it. Do you understand?
Yes, thank you very much.
Yeah, so that's how it works. So I think someone said he wants to add a clarification to the question. Oh, okay.
But I think in terms of database in China, they have their own database in China. I think that's what this guy is trying to point out. Like, if you want to do anything on the AWS in China, the data center has to be in China, not in US. The data should be in China, not in US. That's the problem. Even Azure, they have their own data center in China, presently in China, physically in China, not in the US.
Yeah, so now that works. But now take, for example, in a situation in which let's take away China, maybe a situation in which you don't have a data, like let's say for an example in Nigeria, there's no data center in Nigeria. But we only want the customers that are in Nigeria, we only want the people in Nigeria to be able to access the application. So in that area, in that sense, what I said earlier will works. But like every of the cloud platform has have a data center. Do you understand? Have a data center in the country that you mentioned. So it depends. So, but what I'm emphasizing on is the way you handle your data. It's what is left to you as an individual to determine who are your customer, what service are you providing, and what is the policy guiding the service that you are providing. Do you have any other person or any other question? So, any other question? Okay, so if you don't have, maybe probably we'll close for today. Then we'll continue tomorrow. I hope you're able to understand the principle behind this. So you're able to understand. We'll continue from tomorrow. It's going to last from tomorrow to Saturday. So tomorrow we'll continue with AWS. And after we are done with that, we'll go more introduction into Azure, then into GCP. So thank you all for showing, and Have a nice rest of evening for those in the West African time. And for other in the part of the world, have a nice day. Let me put it in that way. Yeah, thank you. I think we can stop.